Okay, so let me get the worksheet back here. So we're going to create gene maps based off of how often things cross over. So let's read the instructions. It says during crossing over, which is during prophase 1 of meiosis, genes on chromosomes can switch places. Crossover is random, but the likelihood that two genes cross over will increase if those genes are further apart. Genes closer together are more likely to stick together and not switch places, right? Which makes sense. So if I had a chromosome, see if it'll let me, it's not gonna let me draw here, anywhere here. But if I had a chromosome and two genes were right beside each other, then those two are more likely to stick together than to be maybe broken apart right at those two genes. All right, so gene linkage maps. Using the crossover frequencies, you can construct a map to represent the distance between genes so you can start to tell where genes are at on chromosomes. This map shows chromosome number 2 of Drosophila, which is just it's a type of fly. The distance between the genes can be written as percentages or as a map unit. So you may see them as 17%, or it may say 17 map units. It's the same thing. The gene for body color and wing size are 17 map units apart. So 17 map units apart here, and then you can see where there is a gene in between these two. In between body color and wing size, there is an eye color gene. So how did they figure out that that's in the middle, where that's what we're going to be looking at? They could figure out that there's 8 map units between body color and eye color, and that there are 9 map units between eye color and wing size. All right, so let's do a sample problem, and they walk through this with us. They give us the crossover frequencies. Now what I'm going to look for is what is my longest crossover frequency, and that is 45. The B from gene B to gene B to gene C has 45 map units. So that is what they've done here on step 1. They put B here and C down here at 45 map units. So now here's the thing is as I'm looking at these others, I know that C is gene A is approximately 30 map units from C. So I'm going to go maybe about right here. Maybe about right here is 30. And I would put that down, which that's going to be in step 2 here in a second. I'm just walking through this. Gene B and D, that's 40 map units. So that's almost as far as C. So D I would have kind of down here by C. Now A to D, these two that I've placed on here now, I know they're 25 map units apart. Okay, so I'm going to try to make sure that that's what that looks like, because I know that from here to here is 45. So if you look at step 2, they've kind of done that. Solve it like a puzzle using a pencil to determine the positions, and that's what they did. They knew that B to C was 45. I knew that B to D was 40. And then I knew that C to A is 30. And I knew A to D was 25. Okay, so it's just kind of like going in steps and trying to figure out these map units. All right. So step 3 is subtraction will be necessary to determine the final distances between each gene. So here's the thing, is I know that from B to A to D, and D to C have to be 45, right? So I know this is 25, and I know from A to D is 25, I know A to C is 30. So this has to be 5. From D to C has to be 5, and that's what they have put right here. Now, I know that from D to B is 40, but I also know from D to A is 25, so I know that A to B has to be 15 MU or map units. All right, so that's what they're doing here. So remember, anytime they give you a percentage, it means the same thing as map units. All right, so then we have practice problems, 3 practice problems here, where you're going to draw a bar just like they have here. So number 1, in Drosophila, bar-shaped eyes, scalloped wings, cross-veinless wings, and eye color are located on the X chromosome. The recombination frequency of each gene is indicated on the table. Construct a chromosome map. So you're going to draw a dark line, like up here, and I'm going to look for what is my longest one? And C to S is my longest at 11 map units. So I put C on one end, S on the other, know that that is 11. And then I would go up here and start maybe with C, and be like, oh, C to B is 5.5. So it is directly in the middle, right? Directly in the middle of your line. And then, oh, W to C is only 3, so that's going to be closer to your C. And you're just going to try to start mapping these out. And this is exactly how they try to map out where genes are on chromosomes. All right, so try number 1, 2, and 3 out and see how you do. If you have any questions at all or need any help, let me know. And have a great rest of your day. Bye.